on sound, and if you have not yet seen the video on the first part, then you can see it in the I button. In the first part, we have discussed about sound, its production and propagation, and in today's video, we will talk about sound waves and their characters. So we all know that sound travels in waves, and these waves are known as longitudinal waves. And as we have seen that if we draw a diagram of wave, so suppose this is a wave, and this wave is also called longitudinal wave. The waves travel back and forth in their position and it moves forward. In this way, sound travels. Now, there are few characters of waves such as amplitude, wavelength, frequency, time period, and velocity. So we will discuss about all these things in detail. Now, as I said that sound travels in waves, so there are two types of waves. One is longitudinal waves and the other one is transverse waves. So the sound mostly travels in longitudinal wave and light travels in transverse wave. If we talk about the definition of a longitudinal wave, then it is a wave in which the particles of the medium vibrate back and forth in the same direction in which the wave is moving. So it is the wave in which the particles of the medium vibrate back and forth, and it is called longitudinal wave. Next, moving on to the characters of wave. First, let us do it one by one, and I will draw a proper image. Suppose this is a wave. There is a upper limit and a lower limit. So this part is called the crest, and this part is called the trough. These two are the main thing which will help us to understand the characters of a wave. Character that we will study is the wavelength. This is the most important character of a wave. And what is a wavelength? So as discussed in our previous video, that we know that sound waves travel in a compression and rarefaction. So compression was that the density of air was higher, and in rarefaction it had a lower density. Okay, let me do it with red color. I think it will be easy to differentiate. These were the rarefaction part. So we know that when sound waves travel, the density and pressure of air changes. So for wavelength, this total length of a compression and a rarefaction and an adjacent rarefaction is called wavelength. The total length of the combined compression and its adjacent rarefaction is called wavelength. So to make it easier, we can do it from here. Suppose this is the center of a crest and this is the center of the adjacent or next crest. So the length between both the adjacent crest is called wavelength. So the length between both the adjacent crest is called its wavelength. Now if we extend this, suppose we can make another trough here. So as I said that the distance between both the adjacent crest is called wavelength. So we can make it as the distance, we can say that the distance between both adjacent trough is also the wavelength, that is they are the same. The distance between two adjacent crest or the distance between two adjacent trough are the same, and these are called the wavelength. So the SI unit of the wavelength is meter and it is denoted by the Greek word lambda. The SI unit of wavelength is meter and it is denoted by lambda. Now we will move on to the next character, which is frequency. Frequency. So frequency is very simple. Frequency is the number of vibrations in 1 second. So if you take a pendulum, suppose if you take an example of a pendulum, so the pendulum vibrates how many times in 1 second is its frequency. So frequency is the number of vibrations in 1 second. So for different pendulums or different objects, there are different number of times of vibrations in a second. Number of vibrations or the number of waves in 1 second. In 1 second, this is very important. In 1 second is called frequency, and the SI unit of frequency, SI unit of frequency is hertz, written as capital H and small z, and the bigger units are kilohertz. So 1 kilohertz is equal to 1 kilohertz. 1 kilohertz is equal to 1000 hertz. Next character which we will study is time period. Time period. I am not drawing this part because time period is related with frequency. That is, there is a relation between time period and frequency. So, and frequency is denoted with the letter V. I forgot to write it. Frequency is denoted with the letter V, just like as wavelength is denoted with lambda. So, frequency is denoted with V. Now, time period is the time taken, simply the time taken to complete one single vibration. It is the time taken to complete one single vibration. So we talk about the time period of a pendulum. So if I draw a pendulum like this is a string and this is a pendulum. Now the pendulum, this is the mean position and these are the extreme positions of a pendulum. So the time taken by a pendulum to travel from its mean position to its extreme end, suppose this is A, O and B. So O is the mean position and A and B are the extreme position. So the time taken from its mean position, that is O, to travel to its left extreme position, which is A, and then again travel back to B and then again back to O. So this full time taken by the pendulum is its time period. I talked about the relation between time period. Time period is denoted with T. So if I talk about the relation between time period and velocity, frequency. So the relation is frequency is actually the reciprocal of the time period. That is, V is equal to 1 by T. This is the formula used to calculate velocity. Sorry, again I am talking about velocity for V. So this is the formula to calculate frequency if time period is given, or to calculate time period if frequency is given. And the SI unit of time period is second. It is second. Now moving to the next character, which is amplitude. So amplitude. Again, drawing a wave. Drawing a wave is pretty easy, so I love to draw this one. And so what is amplitude? Amplitude is the distance between, this is the mean position, this is the mean position of vibrations, and amplitude is the highest distance between the mean position and its crest or this one, the trough. So this one is the amplitude. The distance, this distance, the gap between the highest crest and the mean position is called the amplitude. About the definition of amplitude, the maximum displacement of particle of the medium from the original undisturbed position, that is, this is the original, this part is the original, the mean part, this is the original undisturbed position. So the maximum displacement of the particle of medium from the original undisturbed position is called the amplitude. So the maximum, let me take the red marker. So the maximum displacement from the mean position, that is original position, is called the amplitude. The maximum displacement of particle from the mean position is called the amplitude. And its unit is, amplitude is denoted by A, and its SI unit. Its SI unit is meter. Moving to the next character of wave. Next character is velocity. So, what is velocity? Velocity is the distance traveled by the sound in 1 second. Distance traveled by the sound in 1 second. Now, the SI unit of velocity is, SI unit is meter per second. Why meter per second? Velocity is equal to the distance traveled. Distance traveled, as I said, distance traveled of by wave divided by the time taken. So distance traveled is calculated in meter, by time is second, time is calculated in second, so it is meter per second or meter second to the power minus 1. We know that the distance traveled by a single wave is the wavelength, which is lambda. So the wavelength is the distance traveled. This is the lambda, and the time is t, time period is t. So velocity is equal to wavelength by time period. Time period, which is in second. So it is calculated in seconds and denoted with t. So here we get another formula, which is v is equal to lambda by t. Confused between the v of velocity and the v of frequency, because frequency is also denoted with v. Now we know that from here we can derive another formula, that is, we know that time period and velocity is, time period and frequency is related. So we know that frequency, which is, I am writing it with red ink so that you can differentiate between it. So velocity and frequency, there is a relation between velocity and frequency also. So this is frequency, and frequency is equal to 1 by t. Frequency is equal to 1 by time period. So from there we can get that t is equal to 1 by v, where v is the frequency, this one is frequency. Now if we substitute the value of t here, so we get that v, black ink v, which is equal to velocity, is equal to lambda by, substituting the value of time period, we get that lambda by 1 by small v, which is frequency. Now from here we get velocity is equal to lambda into small v, which is frequency. So here we get two formulas. One is velocity is equal to lambda into frequency, or velocity is equal to lambda by time period. That is, velocity is equal to lambda, which is wavelength, by time period, and velocity is also equal to wavelength into frequency. So in today's class we will learn this much only, and in the next part we will talk about some other characteristics of sound, which is pitch, loudness, etc., and some other parts also like echo and all. Thank you.